Welcome to another segment of my video. So we continue from where we ended under current physics, Ohm's law. So remember from my last video I did highlight what Ohm's law states, which they are going to be asking you in the exam. So Ohm's law states that the potential difference in a conductor is directly proportional to the current at constant temperature. Now this can be expressed mathematically as the potential difference is directly proportional to the current. So when you introduce the equal sign, you introduce a constant, but our constant here is going to be R, so it is going to multiply by that. And this gives you the famous formula for Ohm's law. Voltage is equal to current times resistance. Remember, we also talked about voltage, but according to Ohm's law, voltage is equal to current times resistor. Now, we can try to put this formula in a triangle. We can try to put it in a triangle formula there, where we can simply say that's the voltage, the current, and the resistor. Now, why am I doing that? Because they can ask you to find the current. So if they ask you to find the current, it will be the voltage divided by the resistance, or potential difference if you want. If they ask you to find the resistance, it will be voltage divided by current. That is what you need to remember. So you can make subject of the formula, but of course you need to remember what Ohm's law states and recall this formula here. Now Ohm's law can be plotted. Ohm's law graphically can be represented on a graph. So Ohm's law graphically. So when we represent Ohm's law graphically, where I try to plot a graph of voltage in volts against current in amps, you are going to have a straight line of best fit. So you are supposed to have a straight line of best fit. Now what is important is that when you find the gradient of this line, the gradient of this line will always represent what we are calling as being resistor, the resistance. Now why am I saying that it will represent resistance? Remember, gradient M is equal to the change in the y step over the change in the x step. So what is the change in the y step? What do you have on the y-axis? It's the voltage. And what do you have on the x-axis? It's the current. What is voltage divided by current? If you remember, voltage divided by current is simply giving you R, which is the resistance. And that's why the gradient of a graph of voltage against current will always represent the resistance of any conductor that you are measuring. Now, such materials that obey Ohm's law, we call them as being ohmic conductors. So they can ask you, so I can write a point there and simply say, materials that obey Ohm's law are called ohmic. So we call them as being ohmic conductors. So materials that obey Ohm's law are called as being ohmic conductor. And how do you know that it is an ohmic conductor? When you plot voltage against current, it will give you a straight line. So the moment you have a straight line, just know that the material you are dealing with is an ohmic conductor. It obeys Ohm's law. Examples of ohmic conductor: most of the metals, but of course not all metals, but most of the metals are simply ohmic conductors, good ohmic conductors, but not all of them, as you are going to to find out later on. So very important concept that you need to remember and actually take into consideration. Now, of course, I want to highlight again, there are some materials that do not obey Ohm's law, and such materials that do not obey Ohm's law are simply called as being non-ohmic conductors. So let me slightly take it behind and actually highlight a few concepts. So I can say, materials, so we can say that materials that, do not obey, Ohm's law are called non-ohmic. So we call them as being non-ohmic conductors. So that is what we call them, non-ohmic conductors. And examples of non-ohmic conductors, we may simply include what we are talking about as being, thermistors. I think I can also talk about the, transistors. I can simply talk about, what we are calling as being a diode, a filament, of a lamp. Yeah, the filament of a lamp. Those may not obey Ohm's law, and therefore we refer to them as being non-ohmic conductor. So in the exam, they can ask you to give examples of, what we are calling as being, non-ohmic conductors. Now, graphically, when you plot, non-ohmic conductors on a graph, I'll put up two type of graphs that you may be able to see when a material is non-ohmic. So voltage against voltage in volts and current in ampere, voltage in volts, current in ampere, because we are putting up the perimeters. You may actually see such a graph, or you may see a graph in that direction. So whenever you see such graphs, they actually indicate non-ohmic conductors, materials that do not obey Ohm's law. This is what you may have when it comes to a filament, and you may produce such when you're dealing with maybe the things to do with thermistors, diodes. You can have such type of graphs coming up. So in my next video, we are going to now focus and look at what we are calling as being a resistance. Let me just say we are going to look at electrical, what we simply call as being electrical. So we are going to look at electrical resistance. So we are going to talk about electrical resistance, and hence we are going to look at factors that affect this electrical resistance. Thank you for watching my video. See you in the next section of the video as I develop some more concept.